What up? With Giancarlo. Thought I'd throw something new in there, class. So we're getting into 3.4 angle relationships. So this is what I'm being told by far the hardest lesson in this module 3. So let's get it. So we're going to start off with measuring angles. It is useful to work with pairs of angles and to understand how pairs of angles relate to each other. Congruent angles are angles that have the same measure. Using a ruler, draw a pair of intersecting lines, label each angle from 1 to 4. So we've got 1, 2, 3, 4. So 1 and 3 are specific angles that you'll learn about on not the next slide, the slide after. And then 1 and 4 would also be angles that you will find out about also. Just getting started, just so you guys have that in the back of your mind. So I want you to take a look at this. If angle 1 is 120, which everybody should know we call this an obtuse angle, and angle 2 is 60, right here, 60, we call that an acute angle. Acute, obtuse, that's a U, and acute, I'm a QT. All right, so angle 1 is obtuse, angle 2 is acute. So just by looking at it, 1 and 3 look a lot alike. A lot alike, okay? So I'm just gonna go ahead and guess it's the same. They're the same. So I'm gonna say angle 3 is 120. What? Unbelievable! It's the same. So just going off that, I can pretty much assume the same thing about 4. Boom, 60, same as angle 2. All right, these are congruent angles. 4 and 2 and 1 and 3 are congruent angles. They're pairs of angles that relate to each other. All right, so 1 and 2, 1 plus 2, that's 180. So we can see 1 and 2, when we put both of their angles together, will equal 180. When you have a straight line will give you an angle of 180. It's just wide open like that. It's 180. So 2 and 3, going to be 180. 3 and 4, 180. It's a straight line. 4 and 1, straight line, 180. All right? So we looked at an obtuse and acute. I just want everybody to know that there's, when you have a little square in the middle right here, that's called a right angle that everybody should already know about. This should be obtuse, acute, and right angles should already be in your brain from elementary school, okay? We should all know that by now. Okay. We're not going to do that. So angle pairs and one-step equations. Here it is, class. So vertical angles are the opposite angles formed by two intersecting lines. Vertical angles are congruent because the angles have the same measure. So I'm going to try my best. I didn't mean to make that little mark right there. So imagine that these are perfect, class. Imagine they're perfect. We had 1, 2, 3. Actually, no, I got to do it a little differently. All right. So there it is. 1, 2, 3, 4. All right. So class, angle 1 and angle 3 are vertical. They are vertical angles because they're across from each other and they have the same, they are congruent angles. Okay? They are opposite angles. You see, they're not next to each other. One is the opposite of 3. It's across from it. So they have the same measure. Well, maybe not in this exact picture, but in an actually drawn, legitimate picture, they would be across and have the same exact angle. Okay, they are congruent. 1 and 3 are congruent. They are across from each other. They're opposites, so they are vertical. All right. Adjacent angles. Okay, adjacent angles are pairs of angles that share a vertex and one side, but do not overlap. They do not overlap. Okay. Adjacent angles share a vertex and one side, but do not overlap. So we've got 1 and 2. Angles 1 and angle 2 are adjacent. They are adjacent. Okay? They're right next to each other. They share a vertex and they share one side and they do not overlap. Okay? So, complementary angles are two angles whose measures have a sum of 90 degrees. So, like I said, that right triangle is 90 degrees. So what we're looking for, this is angle 1, this is angle 2. Angles 1 and 2 in this picture right here are complementary. Angle 1 and angle 2 are complementary. So, supplementary angles are two angles whose measures have a sum of 180 degrees. You discovered in the Explore activity that adjacent angles formed by two intersecting lines are supplementary. So, 1 and 2. Angles 1 and 2 are adjacent and supplementary. All right? Because they make a straight line. Angles 1 and angle 2 make a straight line, and that will equal 180. All right? Class, I'm telling you, if there was ever a time to take down notes, pause the video and take notes right now. Okay? Vertical angles, 1 and 3 are vertical angles. Even draw the crappy little drawing that I made about the angles. All right? Vertical angles, 1 and 3 are vertical. So you just know. Adjacent angles, okay? 1 and 2 are adjacent angles, so you can see them, okay? Maybe jot down same share vertex and one side. Don't overlap. All right? But please, 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 this is very, 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 very important. Complementary, 90 degrees. Complementary, 90 degrees. Supplementary, 180. Oh, hey, Mr. Giancarlo. I was wondering what's the sum of two angles for complementary? It's 90. Okay? Supplementary is 180. Supplementary 180. Complementary 90. Supplementary 180. Complementary 90. All right? Please remember that. Okay? Jot all this down. You got your little 90, you got your 90 degree angle, the right angle, and then we split it in half. 1 and 2 are complementary. 1 and 2 in this are supplementary. So this is, I'm going to change that. Maybe it's a little distracting. We'll go with 5 and 6. 5, 6. All right, better. All right, moving on. Use the diagram. So now they throw in a little bit extra, okay? So name a pair of vertical angles. So this is how it works. AFB and DFE. That is how you name an angle, okay? You listed 3 points. When they give you points like this, it would be AFB and DFE because they're opposite. They're across from each other. They're opposite, and they are not next to each other. All right? Name a pair of adjacent angles. Adjacent angles. So there's a good amount here. So AFB and BFD. AFB and BFD. They share F, which is the vertex, and they share this line right here. AFB, BFD. BFD, big freaking deal. It is, class. You need to know it, okay? AFB, BFD, adjacent angles. Take notes. Write this stuff down. It's important, okay? Name a pair of supplementary angles, okay? AFB, BFD, okay? Adjacent angles are most likely, but not always, supplementary angles, okay? Name 2 pairs of supplementary angles that include DFE. Okay, so I've got DFE and AFE. Oh, they use DFE and EFA, which is the same thing. I was talking about that, but they just go EFA. So I guess it's DFE, EFA. All right, try and do it that way. And then we're going to use DFE and DFB. DFE, DFB. So, right, this straight line, which includes this angle and this angle, which is the mandatory one. So let's make our own drawing. It's right here. So we use this one, and then we use this one. All right? There it is. Nailed it. Boom, perfect. We're the best. We're the best. All right. Moving on. So, find the measure of AFB. Ooh. If AFB is supplementary with BFD, ooh. So they show you. So they show you that this is a right angle. So really what this is x plus 50 plus the right angle is 90. Okay? Equals 180. 50 plus 190 is 140. So x plus 140 equals 180. Then I'm going to subtract 140 from both sides. And I'm left with x equals 40 degrees. All right. And I did it right. Oh my God, I'm so smart. I'm the coolest person alive. What is the relationship between AFB and BFC? AFB, AFB, and BFC. The relationship between AFB and BFC, they're complementary angles. They're complementary. The sum of their measures is 90 degrees because we found out x is 40, 40, and 50. So they equal 90. They are complementary. They are complementary angles. Complementary 90, supplementary 180. Complementary 90, supplementary 180. Okay? Do not forget that. All right. Are AFC and BFC adjacent angles? AFC and BFC adjacent angles. Are AFC and BFC adjacent angles? AFC, BFC. Class, are they adjacent angles? If you took down notes, you would know that they are not, for the very specific reason that they overlap. They cannot overlap. They overlap, and that is why they cannot be adjacent angles. They overlap, and that is why they cannot be adjacent angles. They overlap, and that is why they cannot be adjacent angles. Yeah, 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 yeah. All right. So, moving on. Name a pair of supplementary angles. All right, your turn. Pause. Do 5, 7, and 8 right now. Waiting for you to pause it. I want you to pause it right now so you can do the your turn by yourself without the answers. Not that catchy as the other one, but you know what I mean. All right. 3, 2, 1. All right. Let's get it. Let's get it, dude. Name a pair of supplementary angles. Pair of supplementary angles. So I'm personally gonna go with EGF and FGB. Those are supplementary angles. I don't know what they went with. So they went with FGA and AGC, also supplementary angles. All right, straight line. FGA and AGC equal 180 together. Okay. There are a bunch of supplementary angles on this. Okay. Name a pair of adjacent angles. Adjacent angles share a vertex and one side, but they do not overlap. Okay, adjacent angles, I'm going to go with EGF, FGB. Same thing I did for the supplementary. Let's see if they did the same thing as they did for the supplementary. So let's see if it's FGA, AGC. Oh, they went a little differently. They went FGD, DGC. Okay, that's a different supplementary, and it's also FGD, DGC, and that's also adjacent angles. Okay, name a pair of complementary angles. Ooh, all right, class. So complementary angles. I'm gonna go with EGF and FGA. Man, they went BG. So class, vertical angle right here and here. So this is 90, this is 90, that's 90, 90. Okay? So they went BGC, CGD. All right? Could have gone the same way. Could have gone either way. Name a pair of vertical angles. So they specifically want you to use FGE. So I'm going FGE and vertical angles. Hopefully everybody remembers. Well, pause the video. Pause it. Do it. All right, you must have paused the video by now. I'm going to tell you the answer now. Well, I'm going to go over it. Name a pair of vertical angles. They want you to use FGE. Vertical angles are across from each other. They're the opposite, and they are congruent angles. They'll be the same exact angle. So FGE, I look across, and I find BGC. BGC. And I click it. BGC. BGC. All right. Next up, let's get it. Find the measure of CGD. Ooh. So class, CGD. I hope everybody remembered that this EGF and FGA are complementary angles. So that means it equals 90. So I've got, we don't know, FGA is X, we'll say it's X plus 35 equals 90. Minus 35 from both sides. So when we do that, 5, 5. So if this is 5 degrees, 55 degrees, and CGD is its vertical angle, this must also be 55. So let's check it, see if I'm right. Oh my God. Yeah. Woo, I did it. I did it. All right, moving on. Angle pairs and two-step equations. Sometimes solving an equation is only the first step in using an angle relationship to solve a problem. Find the measure of EHF. EHF. Okay? We see, as we can clearly tell, there's a straight line, so they are making a supplementary angle, okay? So we have to write out the equation. So we get 2x plus 48 degrees equals 180 degrees because they're supplementary angles, okay? So real quick, this is just a regular equation, class. So I subtract 48 from both sides, and then I get 2x on this side, and I get 132 on this side. Then I need my x all alone in its multiplication, so I do the opposite from both sides, and then I get x equals 132 divided by 2. They tell me is 66. So that means x equals 66. So 2 times x. So we are confirming that 2 times x is 66, 2 times 66 is 132. So EHF is 132. When we add 48 to it, we get 180. So they're asking for EHF. They're not asking for x. So we would do 2 times x, and we would say angle EHF equals 132 degrees. Don't worry about putting degrees on the quiz answers. Just put the number, okay? All right. Same exact thing, class. This is complementary. We see it's a right angle. So we do 4x plus 7 plus 35 equals 90. Add these both together. 7 plus 35 is 42. So 4x plus 42 equals 90. Subtract 42 from both sides. I get 4x equals 48. Divide both sides by 4. I get x equals 12. So we're specifically looking for z, x, y. All right? So now I plug 12 into this equation. So it's 4 times 12 plus 7 equals 4 times 12 is 48 plus 7. 48 plus 7 would be 55. 55, class, right there. All right? So we would just put 55 in the answer. All right. So write and solve an equation to find the measure of JML. JML. They already give you the equation. You got to solve it. I'm going to pause. This is easy. This is the easy math that we've already gone through. So pause it. 3, 2, 1. That was enough time for you to pause it and work it out yourself. This is how you solve it. And then to find JML, you multiply, you work it all out and get x. You subtract 54 to this side. You subtract both sides by 54. You get 3x equals 126. You divide both sides by 3. And you get x equals 42. Then you plug x back into this equation to find out, no, you do 3 times 42 to find out JML. All right? And I don't want to do that one. And that's it. So, quick shout out to my boy Big Joe. This one's for you, big dog. And all my loyal fans. And everybody remember, if you're watching this video, you're a part of the class. Have a nice day and stay safe, everyone.